This is a video report for Geotechnical Hazard Group projects, and my name is Duan. My partner is Zetong Liu and Chen. A road needs to be constructed to access the bottom of an open mine pit. Our role is to use the optimal software to propose possible designs for the cutting that minimize the volume of excavated material. There are four main requirements.
Now I'm going to introduce two retaining wall designs. The first one is piling retaining wall. Keep the width of the piling retaining wall as 1 meter and only change length L to find the best design. The first trial is to make L equal to 5 meters. After running analysis, we find that its safety factor is 2.550, which is out of the range of 1.4 to 1.5. Then the second trial is to decrease length to 4.6 meters, but the safety factor is also not satisfactory. By using binary research, we found that the safety factor of the length of 4.65 meters is 1.464, which is satisfactory for the project. And the video shows the way it might fail. It can be seen that the lower slope is more critical and easier to fail, and there are some stress and strain diagrams of the design. The second retaining wall design is pile retaining wall with anchoring. The length of the anchor is 8 meters, and only change the angle between the piling wall and the anchor to find the best design. The first trial is to make angle equal to 35 degrees. After running analysis, we find that its safety factor is 2.021, so it is not satisfactory. After several times trials by using binary search, we found that the safety factor of the angle of 14.04 degree is 1.434, which is satisfactory for the project. And the video shows the way it might fail. It can be seen that the lower slope is more critical and easier to fail. And there are some stress and strain diagram of the designs.
Design 2 that only involves excavation works. So how could we determine the excavated area and the field area? Now I'm gonna solve this problem mathematically. According to these two equations, we can get h1, and we can assume this part equal to beta 1, and then we can get area 1. Similarly, we can also get area 2. The area of slope 1 should equal to the area of slope 2, so we can simply get L1 and L2. I created a spreadsheet to calculate L1 and L2. As long as we input the angles of the two slopes, the width of the two slopes can be calculated directly. And these two rows are used to check if my spreadsheet is correct. Build the model and set the boundary conditions, and the parameters of material 1 is 35, 5, and 20. And for material 2, it's 32, 3, and 22. Then we add a UDL, which is magnitude 20 kilonewton per meter on the surface of the road, and set the mesh, and then run analysis. The factor is 0.449. We have tried different angles of slopes and run analysis until we get the satisfied safety factor. This is the stress distribution of stage 6, and this is strain distribution, and we can predict that the critical slope is slope 1, and this is the failure model. Finally, the two angles of the design are 48 and 36 degree, and the safety factor is 1.486.
This is the design of our cantilever retaining walls. Two cantilever retaining walls are used in this design, and the width of the wall is assumed as 1 meters. We change the lateral size B to meet our requirements. Our first trial, we chosen the B is 2 meters. This wall, which is larger than 1.5. So we change the lateral size B from 2 meters to 1.5 meters. And also using the optimal software, we can predict the failure mode and the collapse multiplier. The safety factor is 1.568, which is also larger than 1.5, and the predict failure mode is the same as trial 1. So in trial 3, we still decrease the lateral side B from 1.5 meters to 1.25. And we modelize that in optimum and run analysis, which is shown like this. The collapse multiplier is 1.202, which is less than 1.4. So using the binary search, we can try our first trial. The lateral side is from 1.25 meters to 1.375 meters. Also modelize and run analysis in the optimum, we can find that the collapse multiplier for this trial is also less than 1.4. Still using the binary search to change the lateral size from 1.375 meters to 1.4375 meters, found that the safety factor 1.449, which is between 1.4 and 1.5, and as shown, they predict failure mode, while the bottom retaining wall is critical similarly as previous trials. So the trial 5 two cantilever retaining walls, the width is 1 meter and the lateral size is 1.4375 meters, is satisfactory. So in summary, we compare our designs and find that between retaining structures and earthworks, the retaining structures can efficiently minimize the excavation works and very flexible to use, but it can also make costs higher. And thanks for your listening.